Hi all. Today we are going to start with this problem statement. Department top 3 salaries. Okay, this is a hard category statement. So in this particular problem statement, we are given with two tables, employee table and department table. If you look into the employee table, we have four columns in which ID is the primary key and department ID is the foreign key, which is the reference column. And in the department column, we have the ID, which is the primary key. So department ID, which is the foreign key, is the same as the ID of the department. So we need to build a relationship between the two. There is a relationship between the two where the department ID of the employee column is equal to the ID of the department table. Okay. So considering this, let's look at what's the problem statement. It's a company's executives are interested in seeing who earns the most money in each of the company's department. A high earner in a department is an employee who has the salary in the top three unique in the top three unique salaries for that particular department. Write a solution to find the employees who are high earners in each of this department, and we will need to return the table in any order. So what this actually is saying, that in this particular table we have the department IDs present between us, okay, and we need to group this particular table on the basis of department ID, and whatever the top three highest salary values of the individuals that we will be getting, that we need to display. And how we need to display, it's given over here. We need to display the department name, and we need to display the employees who have the highest, the top three highest salary values with respect to the department. So one thing is clear, that we need to build a relationship between these two tables. And if you look at the top three values, right, but here four values are coming for the ID. Why? Because the two values for Joe and Randy, if you can just see, they are the same. And so these are both categorized as rank 2. So one thing is clear, that we need to use the dense rank function in this particular case, because the dense rank, what it will do for same values, it will give you the same rank. Okay, and then we can use that dense rank function, and then we can say that please fetch me the value of those individuals, the salaries of all those individuals where the dense rank is less than equal to 3. Okay. So let us start building the query. Let us see step by step what we need to do. Okay. So first thing, we need to create a table in which the ranking of all these salaries on basis of department ID is established. So let us see that. So what we need to do, let us have the name, the salary, the department ID, okay, and let us now use the dense rank function. So dense rank function goes like this. First we use the dense rank over, because this is a window function, so over partition by, it acts like group by, so it will say that like how we are going to group it by. So we are going to group it by through department ID, so department ID, and then order by salary. And in which order we need to display the salary? In descending order, because we need the top three values. Okay, so descending order, as alias it as RN. From which table? From the employees table. Okay, from employee. Let's run this and see what output we get. So if we go down, if you can just see that now we are getting the ranking of all the employees belonging to respective department. See, all the department IDs are grouped together, 11111, and all the rankings are here. So for Max it is 1, for Joe and Randy both are having the same ranking, and for Will we are having 3, right? So we are having it like this. For Henry we are having 80,000, which is rank 1. For Sam it is 60,000, which is rank 2. So, and this is department number 2. So we need to display the top 3 values, okay, department wise. So now we are going to store this in a temporary table. Let's call it as CTE, or let's call it as temp, whatever, whichever name you want to. And now what now we need to do is we need to establish a relationship between these two, because if you can just see in the output, we don't need the department ID, we need a department name, and the name is present in the department table. So we need to build a relationship. So we are going to use left join in this case. We can also use inner join, but left join will work faster because we need all the values from the employee table and nothing from the department table. So select d dot name, and I am using d dot name because I will be aliasing the department table as d. So d dot name will suggest that I will have the department name first. So d dot name, let me alias it as department, okay, comma c dot name, c not c, sorry, d dot name, let's say d dot name as, now let me alias this d dot name as which is the second in group, that is employee, as employee, and your d dot salary details, right, d dot salary as salary, okay, from your temp table, correct, from the temp table, and let us present the temp table as t, okay, left join the department as d, okay, on. Now what is the joining condition? We need d dot, from the department we need the id, okay, which is equals to t dot, we need the department id, correct, we need the department id, where my t dot, now see the rank. Now we have built the table based on, we have built the entire table, but we don't need all the values, we need the top 3 values. So here where the ranking will come into picture. What will be the ranking? Ranking will be all the values where the rn value is less than equal to 3. So where t dot rn is less than equals to 3. So this will give me the top 3 values. I think the query is correct. So let me just run this. Okay, it has accepted. Let me submit it. Okay, so it has given me the output. So it is running correctly and it beats 82.37%. So the runtime is 982 milliseconds. So the solution is quite efficient and it has provided me the value. Okay, so thank you for watching. If you liked this video, then please don't forget to subscribe my channel.